for representation of functions. Now, I just want to take a couple of minutes to talk about the different ways that you can represent a function and just explain briefly why they all say the same thing. So here we have a drive-in movie theater charges $4 per car. There's that word per again, which means $4 per car is the rate. So one car, $4, two cars, $8, and so on and so on. Plus $3 per person in the car. And that's another rate. Interesting. Let's see how that plays out here. Create a function that represents this situation. Let x represent the number of people in the car and y represent the total cost. Okay, so we'll have some clarification now. $4 per car. This situation is only for one car, and you're looking at how many people you put in that car and how much it's going to cost total. So this $4 per car is not a rate. This is the initial. That's the initial charge. And this $3 per person in that one car is the rate. So it is important not to just look at the keywords all the time. You need to think about what's going on, and that'll help you process the initial amount versus the rate. Okay, function table. Let's see. Number of people in the car is 0. Total cost of the movie $4. That's great if your car wants to watch the movie, but that's not really a realistic situation. I mean, who's going to park their car and then pay $4 and then leave or something like that? But anyway, what if you have one person in the car? That would be $7. So that may not be the most economic choice because your car doesn't really enjoy the movie as much as you do, probably, unless it is the movie Cars, and that's a whole other story. But anyway, plus 3. And then plus 3 to get to the next one. So if it goes 1, 2, 3, 4, 5, 6, every time you add another person in the car, well, you have to pay another $3. Plus 3. So obviously the more people you cram in your car, the better total value it is. So this pattern continues, and plus 3 again. Always plus 3, and that's what a linear function is, always the same rate of change. Notice here, $3 per person, there's your rate. Let's take a look at the graph. The initial is $4, that's right here on the y-axis, boom. And then $3 per person, that's your rate. So you go up 3 for each increase in the x-axis. So it's 3 and 1, 3 and 1, 3 and 1. Always 3 up and 1 over. That's your rate of change. So 3 is the amount of change per 1, or the rate of change. So notice this graph says the same thing as this function table. So if you were to plot these points as ordered pairs, 0, 4, 1, 7, 2, 10, 3, 13, that's how you generate this graph. Function in words. Well, you could just take this initial representation, function in words up here, where you charge $4 for the car and then $3 per person in the car. But this is kind of a simplistic way to look at it. Take the number of people, multiply by 3, and then add 4. And that's really how you figure out the total cost. Function equation, y equals 3x plus 4. 3 is your rate of change, 4 is your initial amount. So this equation says the same as this table as this graph. In fact, you can use this equation to generate this table using the inputs of 0 through 6. You get these outputs, and that'll make your graph. And this verbal representation just tells you what's going on in words. Okay, so hopefully this helped clarify the 4 representations of functions and how they're related to each other.